All right, guys, I need y'all on worksheet number 4. All right, so yesterday we talked about half angles and double angles, right? Wait a minute. What's today? Tuesday? Yesterday you had a free day. Friday, didn't we talk about half angles and double angles? Okay, so hopefully you have all those memorized and you're moving on to sum to product, product to sum, triple angle, stuff like that. And again, get on it tonight. It takes time. You know, you give me 2 months to walk a marathon, it's not a big deal. You give me 24 hours, it's going to be a bigger deal. You give me 4 hours, it's going to be a really big deal. Okay? So if you wait till the last second on these, just expect it to be troublesome.
A lot of slashes.
I'm censoring myself. So here we go. Now, right here, I see an identity. Okay? It looks like I am adding the cosine of 2 values that are not on the unit circle. Now, you might look at this and go, oh, I could do cosine of 75 with an alpha plus beta identity. True, you can. It's possible to do that. You could do cosine of 75 with a half angle, right? 150 over 2. Or the alpha plus beta, you could do it 45 plus 30. I could do cosine of 15 with an alpha minus beta, 45 minus 30. Or with a half angle, 30 over 2. But this says don't use sum or difference or half angles to simplify. So what do? Well, that's where the sum to product identities come in, or possibly, in this case, the product to sum identities. And if you look, you're going to see 4 of them that look very similar to each other, with maybe something switched and a sign, positive, negative. Well, there's a sum to a product identity for 2 cosines. And if you see it, what do you see? I'll write the identity first. The identity says, let's see. I hate you. Okay. Now, okay, so there is a sum to product identity. It says if I have a cosine of an alpha plus a cosine of a beta, I can change it into what? Y'all see the identity on your identity sheet? 2 times what? Cosine of the, add them over 2 times the cosine of the, subtract them over 2. That's the identity that says cosine of an angle plus cosine of an angle, sum can be changed to a cosine times a cosine product through this formula. So all I have to do is go, well, if my alpha and beta are 75 and 15, I can rewrite this as 2 times the cosine of, add them together and divide by 2, times subtract them from each other and divide by 2. And that gives me 2 cosine of 90 over 2, which is 45, and 60 over 2, which is 30. And I've converted this from a sum to a product, and magically I see the angles on my unit circle, so I can take the cosine and the sine of them and get root 6 over 2. Who knew? Number 2, I see what? A product of 2 trig functions. Now listen, these aren't like naturally in your brain yet, so you're probably not even thinking that this is an option. You're probably hyper-focusing on this sine of 52 and going, well, what can I do with that? I guess I could half 105 and do a half angle, which is going to be a problem because I don't even know 105. But I guess cosine of 105 would show up in that parentheses, and then maybe you could do an alpha minus beta inside the radical. You could maybe get there, but not if I can't use sum or difference or half angles. But wait, What do I have? A product to a sum identity. Now, what is the product to the sum identity? For sine of alpha, sine of beta. Do you see it? Sine alpha, sine beta? 1/2 the what? Cosine of the difference minus cosine of the sum. That's my identity. So if I have the alpha and the beta right here, and if you're looking at that going, why on earth does that work? You can look at the proof and it makes sense. You'll look at it and go, oh, that makes sense. And in a million years, it's not going to help you remember it. Or I would teach it. So I'm going to just stick to my proof and go, all right, according to this, cosine of the, subtract them, 52.5 minus 7.5 degrees, minus cosine of the 52.5 plus 7.5 degrees. And it's got to be in that order. So I get 1/2 cosine of 45 minus cosine of 60. Oh my goodness. And once again, I have trig functions that I can work with. Root 2 over 2 minus 1/2. When I clean that up, I get root 2 over 2 times another 1/2. Sorry, root 2 over 2 minus 1 over 2 times a 1/2, which is root 2 minus 1 over a 4. Who knew? Are you seeing that? Right here. 3 sine of 20 minus 4 sine cubed of 20. Look familiar? If it doesn't, guess why? You don't know your identities yet. But there's a triple angle identity that says that the sine of 3 times an angle, or just 3 theta, is 3 times the sine of an angle minus 4 sine cubed of that angle. And that's actually something you could prove. Again, it's probably not worth it on a test, but you could prove that using an alpha plus beta, or like a alpha plus beta identity, or kind of like a double angle identity. But you could do an alpha plus beta using theta and 2 theta, 3 theta, and do it and then make a couple substitutions and you would get there. I can show you that if you have time to do that. Anyway, if I know the identity, I go, wait, this is this part. So all I got to do is take the theta that I see here and put it there, triple it, and take the sine of it. So all of that is just sine of 3 times the theta that's in question. Oh goodness, that's just sine of 60, which is root 3 over 2. Tangent squared 15. Look familiar? If you're hyper-focusing on the tangent of 15, yes, you could do a half-angle identity here. The power-reducing formulas literally are the reason that half-angles exist. I mean, that's the reason they exist. So literally, if you take, think about it, you take tangent of theta over 2, and what is your half-angle identity for this? Or what else? Which one did I use here? Yeah. So this is what? 1 minus cosine theta over 1 plus cosine theta? You with me? What if I said let theta equal 2 alpha? Right? And then I squared both sides. And that cancels. Then I square both sides. What do I get? Tangent squared alpha equals 1 minus cosine 2 alpha, 1 plus cosine 2 alpha. That's the power reducing identity. There's a power reducing. So I can get rid of the squared part by just coming to this formula. So if I know the power reducing identities, I can go, oh, well, this is just 1 minus cosine of twice that angle over 1 plus cosine of twice that angle. Now, could you do a half angle and then square both sides? You could, but this is the one time when that square root one's nice. If you did this for the half angle, right, and then substituted 2 alpha in there, you end up getting this, which there's nothing wrong with this for finding that alpha, right? And then you square it, you end up getting a little bit bigger mess. Maybe not. But here, when you square the square root, it just goes away and you get a nice clean value. So all I have to do is clean this up, which is 1 minus cosine 30, right? Over 1 plus cosine 30. And at this point, I would probably get rid of the fractions by multiplying the top and the bottom by a 2. And then I would probably rationalize the top and the bottom with the 2 minus a root 3. And that gives me a 4 minus a 4 root 3 plus a 3 over a 4 minus a 3, which gives me a 7 minus 4 root 3, I think. Unless I've got little carols. But that's a power reducing. Do you need any of this junk? No, you just need to know that identity. The power. These are all new identities to you guys this year. Look at number 5. What do you see? If you are hyper-focusing on that and that, you're looking at half angles or alpha minus beta identities, which is okay unless the directions say use a sum to product. This is a sum of a cosine and a negative sine of the same angle. Do you have a sum to product identity right there that takes cosines and subtracts sines? You don't. But guess what you do have? You have one that takes sines and subtracts sines, right? Can you change a cosine into a sine? How? A cofunction? So why don't we just change that first cosine, let's just say, into the what? The sine of 90 minus that? So that becomes the sine of 90 minus that, which would be 75. Do you have a sine of alpha minus sine of beta sum to product identity? It's ugly, and it looks a little like that first one, which was cosine of alpha plus cosine of beta. But you can do it, right, if you have it memorized. So you end up with 2 cosine of something times sine of something. And you're cosining what? The sum of those over 2, and you're signing the difference of those over 2. And if you're looking at those and going, holy crud, they all seem so similar. How am I going to remember each one? That's what I'm talking about. It's Tuesday. That quiz is Friday.
I thought, isn't the second quiz just this?
Yeah. The second quiz is Thursday, though. And then Friday, I add either sum to product or product to sum.
Product to sum and power reducing.
So the product to sum, like we used on number 2 and like we're going to use on number 6. And then on Monday's quiz, which will be over everything, I'll add in the sum to products. So you got to start memorizing them. They don't come easy. I'm not kidding you. I forget them every year. I've done them for 20-something years. They're not easy to get unless you're one of those really great memorizers. And even then, it can be tricky. You've got to spend some time with it. All right, so anyway, I get a 90 over 2 here, which is a 45. And here I get a 60 over 2, which is a 30. And I've changed these unrecognizable or fairly difficult angles that aren't on the unit circle to something that is. So root 2 over 2, 1/2, cancels, and I get a root 2 over 2. What about 6? That will be an identity on your quiz on Friday. Y'all see it? A cosine angle times a sine of angle. And by the way, it could be a sine angle times a cosine angle. The order that you have commutative properties, you have the right to flip them around. But on this one, what does it say? 1/2 times the sine of something, is it minus the sign of something? Yeah. Plus on the first, minus on the second. So alpha 1575, alpha beta, and over here 1575. And look, the order that you do them has an impact. If I put the 75 first and then the 15, I get sine of 60 as opposed to sine of negative 60. There's a difference there. Maybe not with cosine, it's an even identity, but with sine, there's a difference. So I end up with sine of 90 minus sine of negative 60. All of that times a half. Sine of 90 straight up is 1. How are you going to do sine of negative 60? You don't have to be fancy. What is the sine at negative 60? So negative 60 could be thought of as 300, but what's the sine of those? Negative root 3 over 2. So negative root 3 over 2. The other way to do it is to treat it like an odd identity and to factor, so it looks like factor the negative out, right? Which makes that plus. And then I'm just taking the sine of 60, which is just square root of 3 over 2, and I add a root 3 over 2. But either, it doesn't matter, either negative, negative, or positive. You end up with what? If you add these together, I'd have to rewrite that as 2 over 2. So 2 plus root 3 over a 2, but then when you multiply by a half, you end up getting it over 4. Product to sum. Any thoughts on number 7? Without assuming the position, assuming you can do this, any thoughts? So think of it as something squared. I have a formula for a cosine squared. I just don't have one for a cosine 4. So I'm going to think about this as, why don't I try cosine squared of 67.5, and then when I'm done, I can just square that. That would work for me. I can get to the 4th power. Well, what's the cosine squared power reducing? And again, remember, power reducings are kind of like the half angles, but they just don't have that square root on them. What's the half angle for the cosine? Right, so if cosine of a half angle is the square root of 1 plus cosine theta over 2, then if I make that substitution with 2 alpha, then this becomes a 2 alpha, that becomes a cosine of 2 alpha. And then if I square both sides, the square root goes away. So the cosine squared of the angle is just the 1 plus cosine of twice the angle over a 2. So I bring the angle down, 67.5. But don't forget that because we're doing a little manipulation, I got to square it. Well, what's cosine of 135? Negative root 2 over 2. Again, I'm squaring it. At this point, you got to decide, what do you want to do? Do you want to clean it up by squaring the whole thing first? You want to clean it up by multiplying the inner part by a 2 over 2? I would probably do that. So if I multiply the inside top and inside bottom by a 2 over 2, I get 2 minus root 2 over 4. Then when I go to square it, I kind of like that a little better. Y'all seeing what I'm doing? Again, if you missed that, I'm multiplying this inside part by a 2 over a 2. Distributing that in. And then I'm squaring everything, which would give me a 4 minus a 4 root 2 plus a 2 all over 16, which is 6 minus 4 root 2 over 16. And is there anything I can do to simplify that? I can divide a 2 into everything and get a 3 minus a 2 root 2 over an 8. So a lot of algebra going on, but does number 8 look familiar? Hopefully you see a triple angle identity. So the triple angle identity says sine, not 3 sine theta, but sine of 3 times the angle in question. The angle in question is pi over 12. If you don't like looking at a pi over 12, you can change it to degrees by multiplying by 180 over pi, you'll get 15. But that doesn't really bother me, pi over 12. I just plug it in there, and that simplifies to the sine of a pi over 4, which we know is root 2 over 2. You seeing this? This one says use power reducing. How can I use power reducing on this thing? Anybody? Okay, so the power reducing formula, you go look at it, says sine squared of an angle is 1 minus sine of what? Twice the angle over 2? Oh, sorry, yes. 1 minus cosine the angle of 2 theta. Well, here, what's my theta? 2x. And it's a 4, not a squared. So I'm going to start with going sine squared of 2x quantity squared. That's sine to the 4th. And now I'm going to do the power reducing for the inside part. Now, what's the inside part telling me? Okay, here's the inside. 1 minus cosine of 2 theta. What's my theta? So 2 times 2x all over 2 squared gives me what? 1 minus cosine of 4x over 2 quantity squared. Now, this is a little bit filthy. Anybody got any ideas? It says write it, the expression in terms of the first power of the cosine. It's going to end up putting me back here because that's where this came from. What?
Use like the sine theta over 2 theta over 2.
It's going to end up putting me back here. Like if I say, I'm trying to write it in terms of the first power of cosine. So you're right that this right here kind of looks like a half angle, but it also looks like a power reducing. And remember, power reducing and half angles go like each other. You're going to end up back with a power of cosine, which is what I'm kind of trying to avoid. What if I just FOILed it out and cleaned it up? I could get 1 minus 2 cosine of 4x plus cosine squared of 4x over 4. Now it said first power of cosine. Do I have first power of cosine right now? No? Well, what can I do then to make this right here the first power of cosine? How about another power reducing? Right? So what if I just pulled that 4 out because it's kind of bothering me? The 1's fine. This is a first power of cosine here. It's fine. But this cosine squared, so I'm pulling that 1/4 out to the outside. I need to make that a first power of cosine. So what does the power reducing for cosine say? 1 plus cosine of what? Twice that angle over a 2. So here we go. I end up with 1/4 times 1 minus 1/4 times that, and I distribute that in. The 2 and the 4 cancel, leave me cosine of 4x times a half, which is fine because that's a power of 1. And then this ends up being what? This expression right here. Sorry?
You like get rid of that on the bottom like that.
What do you?
Like multiply everything and go by 2.
Am I allowed to just multiply by 2?
No, but when you move it to the outside.
I could move it to the outside and make it a half, or I could break it up as a 1 over 2 and that over 2. If I break it up as a 1 over 2, When I distribute the 1/4 in there, I get a 1/8. And if I break it up as a that over 2, when I multiply the 1/4 in there, I get another 1/8, but this time cosine of 8x. Does that make sense? Yes, no? Trying to skip a step. So I broke that up into 1/2 plus cosine of 8x over 2. And then again, I'm distributing the 1/4 in. 1/8, 1/8. And at this point, I could certainly add those two together, right? And get a 2/8 plus a 1/8 is 3/8. So at the end of the day, if I add that and that together, that gives me 3/8. And have I written everything as the first power of cosine? Yeah. Are you going to have a problem like this in your test? No. I'm just saying, I'm following directions. This is totally something that would show up in a Vestavia test. It's not something we can't do, but we can't do it at all without identities. We have to have those power reducing identities to get rid of the powers to be able to answer a question like that. Otherwise, I have the second power of cosine, fourth power of sine, all kinds of stuff. Product to sum, to write this product as a sum or a difference. This is something on your quiz on Friday. So what about power to sum?
I thought this was on this Thursday. But it says,
Thursday is just going to be half angles, double angles, and what? Triple angles?
oh.
So you've already learned doubles and halves from last year. Triple angles will be new, but that's just two identities. One for cosine, one for sine. And then the Friday test will include the products to the sum, like 10 and 11, and then the sum to the products, like 12 and 13, will pop up on Monday, along with all the other ones, and then Tuesday we'll have everything. But Monday and Tuesday stuff goes on next 9 weeks. So if you tank, I'll ask you, if you tank a quiz, you can drop it for the first 9 weeks. If you don't tank it and have all good quiz grades, you can save your drop for the third 9 weeks, which might be nice. Because the more I add, the harder these get, I think. What about number 10? Product to sum identity. Any thoughts? Do you have a cosine times a cosine? Product to sum? What is it? I don't think it's sine, is it? So I got a 1/2, right? And this says cosine parentheses plus cosine parentheses. And the identity has the minus first and then the plus, but because these are positive, it doesn't really matter. So if you want to rewrite that, if it helps you, great, rewrite it. If it doesn't help you, leave it like it is. But you have some flexibility there. So I'm going to go, the angles are 2 theta and 4 theta. So I'm going to go 2 theta minus a 4 theta and 2 theta plus a 4 theta. So what do I end up with? Cosine of negative 2 theta plus cosine of 6 theta. But what's negative 2 theta with a cosine? What can you do with a negative? Just drop it. I really don't need that because it's an even identity. And I don't know how to go any closer than that, so I would just stop. And some people would argue, oh, well, if you started with this, you haven't finished PEMDAS because you could still add those together and then multiply. And you're right, you'd end up with this. And that probably, to me, honestly, that looks better. But the direction said rewrite it as a product, the product as a sum or difference, so I'm just following the directions. But if I had the choice to leave it like a sum to a product or a product to the sum, to me this looks like a bigger expression that can be consolidated more into a single expression, which is this. So I would probably rather end up there except for the directions. What about 11? Since it didn't help me go any further. Number 11 says product. You have a sine and a cosine. Any thoughts? Product to sum identity. What does it say? So 1/2. And you have a sine of the something. Then what? Of the difference. So sine of the sum, sine of the difference. The sum would be x plus y, x minus y. The difference is going to be x plus y. But what happens when I plug an x minus y in here and subtract it? Negative x plus y, right? You see that? I had to distribute that negative when I plugged that in there. So here, the y's cancel, and I get sine of 2x. But here, the x's cancel, and I get sine of 2y. And I really can't go any further, and honestly, I liked it better the way it was. But doesn't really matter what I like. It said write it as a sum or difference, and I did. (12 and 13). Use the sum to product to write the sum or difference as a product. So if you have a sine of a blah plus a cosine, plus another sine of a blah, what identity am I using? So I got 2 sine of x plus something over 2 times the what? Times the cosine of the something minus something over 2. And my somethings are that and that. So I'm going to plug the x plus pi over 2 there, x minus pi over 2 here, x plus pi over 2 here. But when I subtract an x minus pi over 2, I end up with negative x plus pi over 2, right? And I distribute that negative in. Here, the pi over 2's cancel. And what do I get? 2x over 2, which is x. So 2 sine of x. But look what happens here. Here, the x's cancel. And I end up with what? Pi over 2 plus pi over 2, which is pi, over a 2. And what's the cosine of a pi over 2? Nothing. So I get 2 sine of x times a 0, so the whole thing is 0. Now, if you're looking at this and going, why would you do that? These are alpha plus betas. Why don't you just do alpha plus betas? Well, I would maybe on a test. If I didn't know this identity, I would pull out the alpha plus beta for that, the alpha plus alpha minus beta, whatever, for that, and I would use those identities, clean it up, and I'd still get 0. But I'm following the directions. I'm using the sum to product formula. So yeah, you have an option on a test. Knock yourself out. Number 13, do you have a proof or a formula for a cosine of an angle plus a cosine of an angle? And it is what? 2 times the cosine of the blah plus blah over 2 times the of the blah minus blah over 2. And what are your blahs? X and 4x, x and 4x. So I end up getting 2 cosine of 5x over 2 times the cosine of, bless you, negative 3x over 2, 3x over 2. And what could I do with that negative? Throw it. Did you say in the river? Throw it in the river. Let's do x right there. Sum to product, product to sum, power reducing. They're just more identities that you have. Anybody stink with meeting a new person and remembering them?
Oh, sure.
Like after teaching for 29 years, and you got 100 to 120 new people a year, and then I went to college I got 2 degrees at Auburn, so I was there 7 years. So I got 7 years of new people. My wife went to a different college. On top of that, she runs a nonprofit that has a whole other community. Like my brain is so full with names. Like I recognize faces. I can tell people that about them. Like I can go, oh yeah, you do so-and-so. I have no idea what the name is. Like my brain's full. It just takes a while to learn new names sometimes. And these identities are like this for a lot of you. For some of you, you're like little machines, man. You sit down with these identities and it's like, and they're there. Great. You have to know if that's not you at this point in your life, okay? You have to know that. If you make 20s on all your quizzes, don't worry about it. Just do what you're doing. If you're like, oh yeah, I don't do that, then start spending some time. I don't know what that looks like for you. It might be, I'm a lover, hater, slash of trig identity note cards. My thought is, if you are going to recite it verbally, then note cards are great for those. If you're going to write them, practice writing. Like literally, if you have a little note card that you're practicing with, look at it, write it down, then flip it over. But don't just say it and flip it over, because that's not what you're going to be doing on your test. But whatever works for you, do it, but don't wait till the last minute. Unless you like it. I mean, people make 4s out of 20 on these quizzes all the time. On the new stuff. At the very end, the last quiz, even if you don't know the new ones, you probably still squeeze out a 14 or 15, 13, whatever. But the ones on Thursday and Monday, no, Friday and Monday, those are a lot of new stuff. Tuesday is everything put together. So at that point, even if you didn't know that new stuff, there's enough old stuff to kind of bail you out at some level. But guys, ultimately, you're going to get absolutely hung out to dry on this test if you don't know your identity. Just the reality of it. How can you use what you don't have?
Is Tuesday still going to be 20 points? Yeah.
All of them are 20.
Wait, so none of them are 80?
None of them are what?
80 points.
You do not have any 80-point quiz. You'll have a
You did
test.
last year?
No, we did not, no.
They add up.
I vividly remember those quizzes. You can not.
Thank goodness. Yeah, and if you didn't know them last year, chances are you didn't suddenly get them through osmosis. All right.
Okay, so please start replacing that.
Oh, and I think I actually, do I have them on here? No, I don't.
You wrote that. No, I would say it's okay because I know you. I had a jury I like so many drinks where I show up late. But then when I didn't know what I should school without any of my summer reading, and I failed. I hope that I didn't. With school, I don't. Like in school, he's like, okay, so we have a test. And I failed because I didn't read it, and I did my podcast. Y'all are nerds.
Y'all have a regular day Wednesday.
Get right.
Have y'all heard anything about a late arrival for seniors for the PSAT?
I heard them all talking about it. I haven't heard.
Okay, I haven't heard. It doesn't matter to you guys. You guys are prepared. Are y'all anybody prepared for the PSAT?
I got it.
Okay, listen. Let me just say this. You guys have.
She's also been preparing for it.
Guys, y'all have one weekend at this point. I know some of you were invited to attend a little PSAT class. If you remember your score from last year, if you were in the high 1300s or you were in the low 1400s on that test, or if you had a numerical number out of 200, if you were like 200 something or high 190s last year, you had a shot of being a PS. The PSAT used to be like just you could bank your college on it. Like you could go to Auburn for free and make money. You could go to Alabama for free, make money, go to Europe for a semester, free computer. Alabama still rewards people heavily when they're PSAT, National Merit PSAT people. We only have 2 this year. Last year we had 13. I would imagine that we'll have more out of this class than we did last year. Last year's class are good, but there's not a lot of like those really great people with both sides of the brain going, which is kind of what you have to be. Guys, take this weekend, go to Barnes & Noble or get on Amazon tonight, order a PSAT book. Guys, take a couple practice tests and go over those questions before Wednesday. You can come talk to me if you got any issues. if you got that, I mean, at Auburn, it's probably worth about $6-7 grand over 4 years. At Alabama, it's probably worth, I don't know, $60,000. It is. They'll pay you to go to school there if you're a national merit. It might be. I've known guys that have had 35, 36 ACTs that didn't get into Vandy, and somebody else in that same class had a 34, but they happened to be national merit and did get into Vandy. I mean, schools value that. It makes them look good in national rankings. It just makes a difference. So if you got a little free time, you can blow it off. I know a guy named Chris Schiller once. You might remember Kate. Chris did not blow it off. He listened to me. He took like 6 practice tests, missed it by a point. And I asked him, I was like, dude, I'm so sorry. He goes, I'm not. I did what I could. I have no regrets. I can't tell you how many dozens of people over the years did nothing and missed it by 1 or 2 points. When I know studying can bring you up 20, 40. I've seen a guy go from 175 to a 215 and get national merit. 40 points studying, you know? So it's not too late to spend some time this weekend, especially if you're one of those. But if you blow it off, dude, somebody who's not as smart as you is going to sneak in there. You've got a week and a day to prepare. That's something. My daughter came up 30-something points. Still was short. I mean, she came up short, but she still ended up doing pretty well in the ACT and got a full tuition scholarship. You know, she probably did the best of the 3, my oldest daughter. But
What are all the requirements?
you just literally make a certain score on the test. Then they make you hop through a couple other hoops that are nothing. You just some formal forms you got to fill out. Once you're a national merit semifinalist, there's like a 90-something% chance you're a finalist. So it's not overly selective as long as you do what you're told, and the counselors will help you with that.
What was this year?
I don't know what the cutoff was last year. I don't. It varies. It's a percentile base. Sometimes it's as small as 206.
It's 213 this year, Alabama.
Well, you don't know. Oh, this past year.
Oh, yeah.
For this current seniors.
Yeah.
It's 213. Okay. It might be 99.5. So, but anyway, I'm just telling you, it's one of those things that national rankings, the reason why we pay for your APs, because national rankings for high schools, one of the things is what percentage of your schools take AP tests. Well, if we made all of our students pay for their own AP tests, not everybody would take them. You know, if you're like, I stink in English, I'm not going to make a 4 or 5 in that thing. I'm just taking it because I want to get a little better. I'm not paying $92. Well, we pay for all those. So we have tons of kids taking them. It makes us look better nationally. Well, the colleges know that number of national merit finalists and semifinalists, that's one of the ranking things. So they're like, ooh, we just pay people to come to our school. Big deal, right? I mean, free tuition, what does it affect us? And it makes them look better. And it can make you get into stuff and make more money. Anyway, just a thought.
Yeah. It's just funny. Go look at my private story. It's hilarious.
Hey, so we were doing the 360 thing.
How many of that people were there?
Luke. Luke was there. 10. Luke, Aaron, Maddie, Sam, Sutton, Nathan and Thomas. Nathan and Thomas. I think you're ahead too. Brandon, there's a few other people. Lots of people. Oh yeah, there was predominantly. The teacher, do you know Miss Higgins? Kay Henson.
Tipton?
There's Kay Tipton, and then Henson's the other lady, not the math.
Kate Tipton's doing the math?
Yes, just a number.
Vestavia?
Or Vestavia. No, it's Vestavia. She taught like 4 different classes at Vestavia.
It's Kate Tipton. She's freaking math legend.
Really? Yeah, she rubbed me the wrong way.
It doesn't matter. She won 14 national championships. This good her.
Older woman. Yeah, short hair. Short hair. Her eyes are like chihuahuas. It's a really, really open, like, man. That's not her.
Her?
Yes.
This one?
Yep. Interesting.
Oh, she's really.
Yeah.
Okay, yeah. Dominated math team, national. 14 years.
She was like, I mean, there was a lot of other people in there who like, we would do like a practice portion and then they would ask like a question about every problem. And James and I were sitting there like, I mean, we didn't really miss it. So we knocked out your homework. But,
We didn't miss it now.
Now, usually my students don't benefit. At least for math, maybe for something else.
No, but it's really frustrating because the lady that does English hasn't really given us many like strategies. And the way she answers, you know what? Okay, when you ask
she said it was okay if we didn't read the test.
or when you ask questions about the English portion, which is what I suck at, like she wouldn't give an answer. I thought the point was like to help you do better strategy wise, but she would just like explain the answer and then circle it. And I don't know. It's just been just frustrating. I don't know what this has to do with anything. But
I was just gonna ask.
Well, the best way to prepare, I think, is just take practice
That's what I was
tests.
about to ask, is just take more practice tests.
If you're weaker in one, spend the next week just doing those practice tests and talking to.
is that you learn at Barnes and Noble?
Probably can, but this late in the game, I don't know what they'll have. I know you can have Amazon ship it to your house in 2 days. Order one like right now. Go into bank and try to find one that has practice tests in it. I mean, I can give you some old ones we have, and I'm sure I've tossed them at this point. Because I bought a bunch for my kids to look through. And my kids didn't end up, my daughter literally went from a 165 to a 206, but the cutoff was like 211 that year. So she had a huge jump.
The predicted cutoff is 213 this year, and they're like 80% correct. I went on the prediction website based on like previous years.
I
And
didn't know what my score was last year.
my score last year was,
Is there a way for me to check?
yeah. Mine, I had a 1380, which translated to like a 203, which was like 10 or 15 points under what we need this year. So, and with more math knowledge this year, I'm pretty sure I'm not going to miss a problem on that. But I'm not banking on that. It has to be a curveball. Oh, pretty simple. But do you have any other recommendations, or just recommendations of where to get the practice test?
I mean, you can go to Barnes and Noble or a bookstore and see what they have. I mean, it's the week before, so I don't know how they stock up. But if you if you go to Amazon, you look up SAT.
How long do you have to test overall?
PSE has 2 practice tests, $17. Here's 2 practice tests, $13. Prince review, 2 full length, $20. Step-by-step video tutorials. Here's a Barron's one, 4 practice tests, $14. I mean, how much are you gonna do in a week? 3 practice tests, $16. And most of these are, there's a Kindle version, so you can have it instantly. It says free delivery by Friday.
Good morning,
Find something that can be at your doorstep. If you have a Kindle, or you can have a Kindle app, you can pull up on your phone. You could do stuff, but I would do that. But you could go by Amazon. I mean, go by or something. They may have one, or just call them up and say, "What kind of PSE?" Even if you just do 2 practice tests, figure out what you missed. Talk amongst yourselves. Talk to Cooley or me if you have a math thing you have an issue with, and it can't hurt.
No.
And if you miss it by 2 points, you did nothing. You're gonna like
of the
punch yourself in the face.
Respect yourself, others,
That
and the
is the
environment.
main thing in the universe.
Make
Not
that
prepared to be like, oh yeah, I'm good, and miss by 2
I can't
points.
tell you how many people who have been qualified as a sophomore and a freshman. And then work
First
as a junior.
matter. Think before you speak.
Because people don't, you look at it, you're like, oh, well, if I'm good as a sophomore, I'm fine. Nobody's studying as a sophomore. They didn't care. As a junior, tons of people study, so a lot of those people that were below, and they're jumping on it because they were prepared and you did right. And they just took your meal.
And that meal is worth $60,000.
Well, it depends on where you go, yeah, like, I go to Alabama.
No, Alabama is worth
That's my money. If you go to Auburn, it's not worth as much. Because they don't care. We don't need that.
I haven't like checked to see what.
AT&T approved calculator.
But
That's Wednesday, working test for all people.
It's the difference, it's the difference between presidential scholarship.
Tomorrow night is also volleyball senior recognition night. Play the Davian Hill.
Oh, yeah, I mean, it's just, yeah, why wouldn't
I'm
I?
out for volleyball tomorrow.